Good morning, dear students. So today our topic of discussion is CA engine combustion chamber design. So already we have covered different stages of CA engine combustion and as well as different SC engine combustion chamber design also we have seen. Now let's discuss what are the types of CA engine combustion chamber design. So the objectives of this small session is first to understand the basic requirement of a CA engine combustion chamber. Then what are the methods of swirl generation in CA engine combustion chamber? And what are the types of CA engine combustion chambers, their relative merits and demerits. So this is the topics that we are going to cover. So what is the basic requirement of a CA engine combustion chamber? So just recollect, in SC engine our focus was mainly to reduce knocking. Therefore we were adopted with short flame travel length turbulence design. But in CA engine we have already seen the knocking is not a big problem. But the problem will be how to get a good mixture of air and fuel. So that will be our prime requirement. So the important function of CA engine combustion chamber is to provide a proper mixing of fuel and air in a short time. This is because of the fact that in CA engine only air is entering in a suction stroke and the fuel will be entering only at the end of compression stroke. So we will get a very little time for mixing of this air and fuel. So the design plays an important part for the proper mixing of fuel and air. And to achieve this, we require an orderly movement of air, which is known as swirl. So swirl is the circular or orderly movement of air which is to be created inside the combustion chamber of CA engine. This is because the fact that if the air is stationary, all the fuel particles will not get air molecules, which will result in incomplete combustion. So we want a continuous supply or orderly movement of air, which will supply the fresh air to each fuel droplet, and also it will help to sweep away the product of combustion. So this is our major objective in designing of CA engine combustion chamber. And this already we know, the fuel is injected into the combustion chamber by an injector, and an injector may have a single or multiple orifice. The hole through which the fuel is entering is known as orifice. If we are using a with single fuel jet, that is with a single orifice, the injector with a single orifice, our fuel jet will be only one. In that condition, the air must be swept in full revolution, that is in 360-degree the air rotation required, which is very high swirl generation, which demands a very high swirl generation. But if you use two jets, so instead of one jet of fuel, if you are using two jets with almost 180-degree apart, then the air has to turn only half revolution. So like that, if the number of jet increases, the swirl required will be less. And if we are using only single jet of fuel, this requires a very high swirl because the air has to turn at 360 degrees. So this is a condition in which the swirl will depend. Now what are the methods of swirl generation? How we are going to generate this orderly movement of air? So we have three methods available. First one is induction swirl. So what do you mean by induction swirl? So induction is another word used for suction. So in this, the swirl is created by the directing the air during the entry to the cylinder itself. That is in the suction stroke itself, if we are creating this movement of air, it is known as induction swirl. And this method is used in open type combustion chamber. So we will see what is an open type combustion chamber in later. So this induction swirl is adopted in open type combustion chambers. Then second method is compression swirl, in which we are forcing the air through a tangential passage into a separate swirl chamber, and during the combustion stroke, that is why it is known as combustion swirl. So in this second type of swirl, the swirl is generated during the combustion stroke with the help of an additional chamber which is known as swirl chamber. So we will see in detail how this works, and it is used in a swirl type combustion chambers. Finally, we have combustion induced swirl. So if you are using a partial combustion in some chamber, some pre-chamber, to initiate the swirl in the main chamber, it is known as combustion induced swirl. And this is mainly adopted in pre-combustion chamber and air cells chamber. So these are another combustion chamber design. So we can see the combustion chamber design is related to the swirl generation. So both are linked. For example, if the combustion chamber we are using is open type combustion chamber, the swirl generation must be induction swirl. Similarly, if the combustion chamber we are using is a swirl chamber, then the swirl generation will be by combustion swirl. And if we are using a pre-combustion chamber or air cell chamber, the main combustion swirl will be generated by combustion induced swirl. So this is a classification based on how the swirl is generated. In the first one, we are generating swirl in the suction stroke itself, that is during the entry of air in the cylinder itself. In the second one, it is generated during combustion stroke. Third one, it is generated by the partial combustion of the air fuel mixture. So that is the how we will classify the swirl generation. Now let's see how the induction swirl is created, or what are the methods to create this induction swirl. So induction swirl is generated by constructing the intake system to give a tangential component to the intake flow as it enters the cylinder. So we have to somehow introduce a tangential component to the air entering into the cylinder. So this can be achieved in many ways. So one method is by shaping and contouring the intake manifold. So like this. So this is the intake manifold which connects the fuel tank or air passage to the inlet valve. So by contouring or by making this in an inclined orientation, we can create a tangential component to the air. So that is the first method, by contouring or shaping the intake manifold. Then this is the second method. So this is a front view of inlet valve, this is exhaust valve, this is the top view. So here you can see here it is masked. One side of the inlet valve is masked. This is shown in the top view here. So that is another method. Induction swirl can be generated by masking one side of the inlet valve, so that the air is admitted only around a part of the periphery of the valve and in the desired direction. So like that we can generate a particular direction oriented air by masking one side of the inlet valve. Then another method, we can provide an extra projection or extra lip over the inlet valve. So induction swirl also can be generated by casting a lip over one side of the inlet valve. So these are some methods used for induction swirl. So they are mainly focusing on the changing the inlet manifold or changing the inlet valve. So it has several advantages, but it has, on the other hand, it has numerous disadvantages also. Let's see. So the advantage is easier starting, that is means mainly cold starting is very easy in induction swirl based engines due to the low intensity of swirl. So compared to other two methods, in this one the swirl generated will be of low intensity. So cold starting problems are less. Then high excess air due to low temperature and low turbulence, which results in less heat loss, and therefore indicated thermal efficiency is high. Due to less heat loss, indicated thermal efficiency will be high in this type of swirl. And another advantage is the production of swirl does not require any additional work. So no additional work is required because we are creating the swirl from the entry of air itself. So these are the advantages of induction swirl. And another one, they are used with low speeds and therefore low quality of fuel can be used. So normally the induction swirl will be used in low speed engines in which we can use a low quality of fuel. Then disadvantage, the main disadvantage is we are using or masking the valve, or we are blocking the valve passage, inlet manifold, etc., which will result in a low volumetric efficiency. Because volumetric efficiency depends upon the amount of air entering, not the orientation of air, so it will be less. That is the main drawback of induction swirl. And the swirl generated is very weak, therefore the air utilization is less, and lower mean effective pressure. This type of swirl generation results in lower mean effective pressure, and therefore we have to use a larger sized engine to nullify this. We have to use a large sized engine, which will result in an increase in cost also. And this is another disadvantage. To overcome this weak swirl, we have to use a multi-orifice nozzle. So already we have discussed, if we are using a single orifice nozzle, the swirl must be very high and it should be 360 degree. But so in this case, the swirl generator is very low intensity swirl. So we have to counteract that with the multi-orifice nozzle. It will result also with high injection pressure is required, and this will lead to clogging of holes and high maintenance. So when the holes are increased in the nozzle, there is a more chance of clogging of hole, that is the blocking of hole by the carbon particles, etc. Therefore it requires high maintenance. So this is another main disadvantage of induction swirl. Then another thing is, in this one the swirl is not proportional to the speed of the engine. Since we are using the swirl in the induction or in the suction stroke, even if the speed of the engine increases, the swirl will remain the same. So it is not proportional to speed. Therefore efficiency is not maintained at a variable speed engine. If the engine is with a very varying speed range, this is not suitable because the swirl will not increase for high speed. And influence minimum quality of fuel, another disadvantage. The quantity of fuel that it will influence is minimum. And the last one is, this type of swirl will result in a complication at high load and idling. So if you are running in a high load condition, similarly if you are idling also, this is not suitable. So altogether it has several disadvantages. It's a very few advantages only. So normally this is not adopted in commercial vehicles, particularly high speed vehicles. Now the other two types of swirl will come in this combustion chamber type, so we will discuss there. Now what are the types of combustion chamber? So already we have discussed the types of swirl, these three types. Then based on this we have combustion chamber types. So mainly we can broadly classify it into two categories: direct injection type and indirect injection type. So in direct injection type, it is also known as open type combustion chamber. So direct injection type combustion chamber is also known as open combustion chamber. So in this type, the entire volume of combustion chamber is located in the main cylinder and the fuel is injected into this volume. So in this type of combustion chamber, we have only one particular combustion volume, that is in the main cylinder itself. So no additional volumes are present. Single volume is available as the combustion chamber. But indirect type combustion chamber, indirect injection type combustion chamber, we have more than one volume available. That is, combustion space is divided into two parts. One part is in the main cylinder and other part will be in the cylinder head. So minimum 2 parts will be there. In some case more than 2 parts are there. So we have a main combustion chamber in the main cylinder, and we have another additional combustion space in the cylinder head. And the fuel injection is effected usually into that combustion chamber which is located in the cylinder head. So fuel injection will be mostly in the cylinder head. And these are again classified into 3 categories, that is swirl chamber. Already we have discussed swirl chamber is where compression swirl is generated. Then we have another one, pre-combustion chamber. This is where combustion swirl is induced. Last one is an air cell type in which both the compression and combustion swirl are induced. So this is a overall classification of CA engine combustion chamber. So based on design, we can broadly classify it into 2 categories. One is direct, which there are only one volume of combustion chamber, and in this we are using induction swirl. And the other one is indirect type. Indirect type, we have minimum of 2 combustion volumes, one main combustion volume in the cylinder and another one and small one in the cylinder head. And these are again 3 categories: swirl chamber in which compression swirl is generated, pre-combustion chamber in which combustion swirl is generated, and finally we have air cell chamber in which both the compression and combustion swirl are induced. So now we will see what is a direct injection. Now we will see more about direct type combustion chamber, that is open type combustion chamber. So these chambers are mainly consist of space formed between a flat cylinder head and a cavity in the piston crown in different shapes. So that is a major difference here. In this type of combustion chamber, we have only one volume, and that too made between the cylinder end and piston crown. So we are not using a flat piston in this case. The flat piston is having a cavity which is known as of different shapes, and we are using induction swirl in this type of combustion chamber. So to counteract that, we have to use an nozzle with multi-hole phase type and with a high pressure about 200 bar. This already we have discussed. In induction swirl, we have to use a multi-orifice type injectors with very high pressure around 200 bar to counteract the low intensity swirl generated. Now we have mainly 4 types based on the geometry. We have 4 types of open type combustion chambers. So this is shallow depth chamber, hemispherical chamber, cylindrical chamber and toroidal chamber. So they are different in geometry. This is fuel injector, position of fuel injector. So shallow depth chamber, the depth of cavity provided is very small. So this is the cavity formed in between the cylinder head and in between the piston crown. So you can see here all these 4 cases, the piston is having a deflection in this upper part in the piston crown, and the combustion chamber is in between this piston crown and the cylinder head. This is cylinder head. And these are used for large engines running at low speed, the shallow depth chamber. And second one is hemispherical chamber, which is having a hemispherical cavity formed between the piston crown and cylinder head. And a small squish is provided, which can be increased by varying the depth to diameter ratio. The squish is the turbulence created during compression of air inside this chamber. It is known as squish because it is a localized turbulence created, which will help the swirl also. So that is increased. We can increase that by increasing the depth. So the depth of this hemisphere can be changed compared to its diameter. And the cylindrical chamber, the third one, it is having in the shape of a truncated cone with a base angle of 30 degree. So this is in the shape of a truncated cone. And the fourth one is a toroidal chamber, and this provides a powerful squish compared to other three. The squish is more in this toroidal chamber. So these are based on just geometry itself. So what are the advantages of direct injection type combustion chamber? This is similar to induction swirl because we are using induction swirl in direct injection type. The advantages and disadvantages are almost similar. So the advantage is the minimum heat loss during combustion because of low surface area to volume ratio and hence better efficiency. So in open type combustion chamber, surface area is very less of the combustion chamber, so this will result in minimum heat loss and better indicator efficiency we will get, and no cold starting problem because the swirl is low intensity. The cold starting problems are less, and we are using a multi-hole nozzle here, so the atomization is more fine. And disadvantage is we require high injection pressure, which requires a complex design of fuel injection pump. So we have to achieve a 200 bar injection pressure. That requires a complex injection pump. Then the necessity of accurate metering of fuel by the injection system for a smaller engine is required. So next we will see the swirl chamber. So we have completed the open type combustion chamber, now we are going to the divided type combustion chamber or indirect combustion chambers. So in that we have the swirl chamber. So the swirl chamber look like this. So you can see here we have two combustion chamber. This is the main combustion chamber formed in between the piston and cylinder head. But we have an additional swirl chamber, a circular or spherical chamber here. Both are connected by a throat, and the fuel injector is at the end of this swirl chamber. And this is a glow plug. What is the function of glow plug? Glow plug is used for preheating the air in cold starting conditions to avoid this cold starting trouble. If you want to preheat air, you can use this glow plug, which will act as a heater. So swirl chamber consists of a spherical shaped chamber located at the cylinder head. This is that spherical shaped chamber. A throat connects the chamber to the main cylinder in a tangential direction. This is a throat which connects this chamber to the cylinder in a tangential direction. And into this chamber, what happens is during compression stroke. So when the compression stroke takes place, the piston is at TDC. 50% of air is transferred to the swirl chamber. So this chamber will contain 50% of air during combustion stroke, and that will create a swirl. While entering this spherical chamber, this air will be having a swirl generation during combustion stroke, and then we will inject the nozzle through the fuel. Combustion takes place. Then after combustion, the products will rush back into the cylinder through the same throat. So that is happening in swirl chamber. What are the advantages and disadvantages of swirl chamber? The advantage is we can use large valves. So we are not using induction swirl here. We are not masking valve or having any projection in the inlet valve. So we can use a large valve for high volumetric efficiency. And single injector we can use. So the cleaning and maintenance etc. are less compared to multiple hole type injectors. We have more smooth engine operation and greater air utilization due to strong swirl. So we are generating a strong intensity swirl. So the air utilization is high and smaller engine we can use compared to the open type combustion chambers. And another main advantage is the air swirl is proportional to speed. So if the speed of the engine increase, what will happen? The speed of piston will also increase. So that speed at which the air is compressed into this swirl chamber will also increase. So like that the swirl will also increase. So it is proportional to speed. So it is suitable to variable speed operations. Now what is the disadvantage? The main disadvantage is cold starting trouble due to high heat loss and strong swirl. So already we can see the advantage of this one is the disadvantage of other one, that is induction swirl or open type combustion chamber, and disadvantage is the advantage of open type combustion chamber. And less excess care and low indicator efficiency due to the high heat loss. Efficiency is less and it will require 5 to 8% more fuel consumption because the work required in combustion rock is more, because we have to push this air to that swirl chamber which requires more amount of work. So it will consume more fuel compared to open type combustion chamber. And another one is decreased exhaust valve life. Cylinder construction is more costly. And it's already we have discussed, the work was absorbed in producing swirl and its mechanical efficiency is also lower. Now we are going to the second type of divided type combustion chamber, or second type of this second type of indirect type combustion chamber, that is pre-combustion chamber. So this is a figure of pre-combustion chamber. It is almost similar to swirl type, but we have some difference here. So difference is we are using a pre-chamber. This is not a swirl chamber, not a spherical chamber, but we are using a pre-chamber in here. This is the main combustion chamber formed between the piston and cylinder head, and we have an orifice instead of a throat. Throat is a narrow passage used in swirl chamber, but we have a orifice, small hole type orifice is there, and nozzle is here. So pre-combustion chamber consists of an anti-chamber. Anti-chamber means a chamber used before the main combustion chamber connected to the main chamber through a number of small orifices. So we can use a number of small orifices in between these two. And pre-chamber is located in the cylinder head and accounts for about 40% of total combustion space. So around total combustion space, if you take the volume, 40% is acquired by this pre-chamber, 60% is by the main combustion chamber. What happens here is during combustion stroke, the air will enter into the pre-chamber, but swirl is not generated because it is not a spherical shape. But then we will inject this fuel through the nozzle. Fuel is injected in the pre-chamber and combustion is initiated. So we will initiate combustion in the pre-chamber, and which results high pressure rise and forces the fuel droplets with air and combustion products into the main cylinder with high velocity through the small orifice or holes. So what we are doing is we are initiating combustion in the pre-chamber, which will result in high pressure rise. So we are providing an orifice here. So this pressure will push the air and fuel with some of the combustion products into the main combustion chamber with very high velocity, and that will help to generate a swirl in the main combustion chamber. So the resulting strong swirl in the main combustion chamber, and the remaining combustion takes place in the main combustion chamber. So that is how this pre-combustion chamber is working. So we are using a combustion in the pre-combustion chamber to generate swirl in the main combustion chamber. So about 80% of energy is released in the main combustion chamber. So only 20% fuel is burned in the pre-chamber. Remaining 80% energy is released in the main combustion chamber. Now we are going to the final type of combustion chamber, that is air cell combustion chamber. It is also known as energy cell combustion chamber. So this is the front view of that type of combustion chamber, and this is the top view. So you can see here, this is the main combustion chamber, this one, and it is a two-lobed. If this look at the top view, it is not a single lobe, but it is having a two-lobe type combustion chamber. This is the main combustion chamber. And in addition to that, we have in the side of the cylinder head, we have a two-part energy cell. So this is known as an energy cell or air cell, which is also having two parts. This is a major cell, this is the minor cell. The fuel injector is in this direction, it is in the main combustion chamber. So this is the front view and top view of an energy cell or air cell type combustion chamber. So in air cell, the clearance volume or the space above the cylinder head and piston is divided into two parts. One is the main combustion chamber, which is in the main cylinder, and it has two lobed. So two lobes are there in the main combustion chamber. Here you can see it is two lobed. Then other one is known as an energy cell, this one, which is again divided into two parts. That is a major cell, this is a major cell, this is a minor cell, and they are separated from each other as well as the main chamber through a narrow orifice. So several narrow holes are there in between this main combustion chamber and this minor cell, as well as this major and minor cells. So all these are connected through a narrow orifice. And what happens as the piston moves up in the combustion stroke, some of the air is forced into the major and minor chambers of energy cell. So during combustion stroke, some air will be going inside this major cell and minor cell. So you can see here the major cell, it is a spherical in structure. So here it will create a combustion swirl. So just to recollect, in this type of combustion chamber, we are using both type of swirl generation. Combustion swirl is also used, as well as combustion induced swirl is used. So during the combustion stroke, the air is pushed into this energy cell. So some amount of combustion swirl is generated in this, mainly in the major cell. Then the fuel is injected through the spindle type nozzle across the main combustion chamber, and it passes across the main combustion chamber and enters the minor cell. So it, after passing through the main combustion chamber, it will enter the minor cell, and where it is mixed with the air inside. So during the initial stages of combustion, when the combustion commences, the main combustion chamber temperature is higher, but the rate of burning is lower because of insufficient mixing of fuel and air. So initially some combustion takes place in the main chamber, but it is very slow rate because there is no swirl in the main combustion chamber. And the burning in the minor cell initially is slower but become more and more rapid, better mixing. So this major cell, the swirl generated in the major cell, will help to increase the combustion takes place in the minor cell, and the pressure build up in the minor cell, which force the burning gas out into the main chamber. So once the combustion speed up in the minor cell, it will, combustion products will force through the orifice, and that will create a swirl in the main cylinder. So we are using a combustion induced swirl with the help of the minor cell. So we are adopting both the swirl generation. Combustion swirl is generated in the major cell. Then after that, after burning takes place, the combustion induced swirl is utilized in the main chamber. In the meantime, the pressure is built up in the major cell, which prolongs the action of jet of steam entering the main chamber, then continuing the induced swirl. So it will continuously increase the pressure rise in this major cell, which will again help to increase this combustion induced swirl. So like that, this system will work. So this is the last type of combustion. We have several videos available in YouTube for the better understanding.
Diesel combustion chambers come in two main types, direct and indirect injection.
One such example.
Both are designed to promote turbulence, to help the compressed air and injected fuel mix well. Engines using direct injection have cylinder heads with a flat face. The combustion chamber is formed in the top of the piston. Sometimes the rim of the piston provides squish, forcing the air to the centre of the combustion chamber. This causes turbulence as fuel is injected into the cylinder. In indirect injection, the piston is fairly flat or has a shallow cavity. The main combustion chamber is between the cylinder head and the top of the piston, but a smaller separate chamber is in the head. Fuel is injected into this smaller chamber. It can have various designs. This is a swirl chamber. It's spherical and connected to the main chamber by an angled passage.
So you can see here the spherical chamber.
Both the injector and glow plug are screwed into the head.
So during combustion
the glow
stroke,
plug preheats the air inside to help start the engine.
Air is
During compression, the spherical shape makes the air swirl in the chamber. This helps make a better mixture of the air and fuel, which improves combustion.
And this is a pre-type combustion
This combustion chamber is divided into a main combustion chamber and an air cell joined by a throat. The injector is in the
fuel
throat.
is injected, combustion is
When
initiated
injection
here,
commences, combustion
help
pressure
the
forces
swirl in
the air
this
to
main
flow
chamber.
from the air cell, where it mixes with fuel from the injector. The rush of air from the air cell produces a rotary motion of gas in the main chamber, which helps make combustion more efficient.
So like this you can find some videos in YouTube.
This
which will help to
pre-combustion
understand
chamber
more
is
about
screwed
this.
into the cylinder head.
With this we are
The
stopping
injector
this
is
session.
mounted in the upper end. Injection occurs near the top of the compression stroke. Only part of the fuel is burned in the pre-combustion chamber because of the limited amount of air there. The high rise in pressure forces burning fuel into the main chamber. This happens very rapidly, which helps make more efficient combustion.